if you remember from 2 tutorials ago, when you create a variable, it stores it in memory. And I also said that each byte in memory has an address. Well, in C, one of the most important things that you'll do is getting the address of a variable. That is the address of the first byte that the variable is using. The address of a variable is always the address of that first byte. And there is an operator in C that will get the address of a variable. And we're going to do that here, and we're going to print it out. So let's create a double D, and we're going to print out the address of where this is stored in memory. And I should warn you that it's not going to print out an integer. It's going to print out a hexadecimal number. And that's because it just uses hexadecimal internally for storing these numbers, and that's how we're going to print it out. So even if you're not familiar with hexadecimal numbers, it doesn't matter all that much. So to print out the address of a variable, or where it's stored in memory, you need %p. I don't know why it's %p instead of %a, but that's how they decided to do it. And to get the address of that variable d, you type the and sign, and then the variable name that you want to get the address for. And this is the same operator that you use for any variable, no matter what data type it is. So all we have to do is run this code, and it should give us a hexadecimal number that tells us where the address for that variable is. There we go. And this one is located at 0028FF18. And now, of course, we could convert that number to a normal integer, a base 10 number, instead of a hexadecimal, which is a base 16 number. But it doesn't really matter all that much. Alrighty. Now I'm going to do this with 2 integers, integer x and integer y. And I'm going to get the address of both of these. %p, and we need the address of x and the address, and the address of y. And we're going to print both of those out. Alright, so 0028FF1C and 0028FF18. Now, there's something very significant about these numbers, and it's a little bit harder to see in hexadecimal. So I think I'm actually going to convert these numbers to regular integers in the base 10 system that we're used to. And you do not need to know what this means. I will explain this in the next tutorial, but it converts what is on the right hand side to an integer, and then we can use %i here to print them out as integers, and that way we understand a little bit easier what's going on. Alrighty, so here we have 2686748 and 2686744. Now you'll notice that this is 44 and this is 48, meaning that this integer y, is starting at position 44, and it's using 4 bytes of memory. So it's using 44, 45, 46, and 47. And then this integer x is actually stored after y, which is a little bit odd, but it starts at 8. That means that these 2 integers are stored consecutively in memory. They're actually, if you actually were to look at them in memory, the bytes for each integer would be right up next to one another. So, in this tutorial, we have used the address operator to get the address of variables, and we can even see how close together the variables are with the address. In the next tutorial, I'm going to be taking a quick break from all this complicated memory stuff and talking to you about type casting. And that's what the technical term is for what I did here. And in the tutorial after that, you are going to get to a concept called pointers. This is probably the most complicated thing in all of C, and if you guys understand pointers, you are good to go for everything else I talk about in C. Trust me, they're that hard, but I think you guys can do it. Alright, thank you for watching this tutorial, and in the next tutorial, like I said, we'll be going over pointers. See you then.